Hello, everyone. Today we will be covering topic 7.5 and 7.6 with the enduring understanding of how human activities have physical, chemical, and biological consequences for the atmosphere. Our main topic today is indoor pollution. This is where it comes hand in hand with something called sick building syndrome, SBS, I'm sorry. This is a term that is used to describe a combination of illnesses associated with an individual's place of work or maybe residence. Now, with many people spending the majority of their lives indoors, sleeping, maybe working, eating, and relaxing, we have air circulation that may be restricted, and indoor air pollutant levels may be 2 to 5 times greater than the outdoor levels. This is a problem worldwide, obviously, and it does contribute to 3.5 global death per year, but it's typically the highest in developing nations. Why is that? Because people over there they burn charcoal and wood, which is crucial for heat generation, cooking, water boiling, but at the same time it also releases particulate matter and carbon monoxide. If you actually take a look at this chart, in developed nations we have the problem of indoor pollutants because these usually come from construction materials such as formaldehyde. They can also come from tobacco smoking. They can come from other chemicals found in drywall and lumber, and they can also or they can also be from particulate matter from wood fires. The main examples of indoor pollutants would be asbestos. This is basically was first used in steam engines, construction, shipbuilding, and manufacturing industries. And it's inexpensive, durable, flexible, and it's a natural insulator and fireproofing agent. So nowadays, it's now mostly used in bakeware, ceiling, flooring tiles, cigarette filters, drywalls, fireproofing materials, insulating materials, plastics, and vinyl products. The problem is it's everywhere, and breathing those asbestos fibers can lead to lung cancer, and the problem is the symptoms do not appear until about 20 to 30 years after the first exposure. The second indoor pollutant would be carbon monoxide. This is basically the carbon monoxide poisoning is the most common type of fatal indoor air poisoning in many countries because it easily contributes or combines, I'm sorry, with hemoglobin, which blocks the blood's oxygen carrying capacity. This can also lead to lung cancers and COPDs, which is basically chronic obstructive pulmonary disease. It also can cause low birth weight, increased infant mortality, tuberculosis, and lung cancers. The third one would be the formaldehyde. This is an organic chemical, so obviously it contains carbon, but it's also an indoor pollutant, and it is a very serious carcinogen. It is linked to lung cancer found in many insulating products such as foam, found in many paper products such as grocery bags, facial tissues, disposable sanitary products. It is also found in other materials such as plywood, floor covering, cosmetics, deodorants, and shampoos. The next one would be the POPs, or the persistent organic pollutants, such as the radon. The radon is an invisible radioactive gas that results from the radioactive decay of radium. So can be found in rock formations, typically granite, and this can be found beneath the buildings or in certain building materials. It's probably the most pervasive serious hazard for indoor air in the United States and Europe. This contributes to cancer, and it is a heavy gas, so it kind of tends to sink and accumulate at floor levels. If we want to mitigate the exposure to radon, we want to probably increase indoor ventilation because the well insulated homes are the homes that could suffer from a radon leak. We could seal the basement foundations, or we could be sealing the concrete slab floors. And it is good to know that it is the second leading cause of lung cancer after smoking, which brings us to the last two. If you have a minute, please, and if you have your books at home, please take a look at the radioactive radon gas, page 615 and 617. The last two would be the mold, and obviously, this is a type of fungus that grows in moist areas. So, you would want to monitor the humidity levels in your house to reduce mold and mildew. And it obviously causes sickness, increases respiratory illnesses, coughing, infections, and so on. Last one would be the tobacco smoke. This is very serious, number one, leading cancer because it contains almost 5,000 chemical compounds, most including 60 known carcinogen. So obviously, main leading cause for cancer, not only for lungs but also for mouth, larynx, esophagus, stomach, pancreas, kidney, bladder, and colon. The problem with tobacco smoke is that in developed countries, it is somehow regulated because people tend to ban smoking indoors, but in developing countries, it's actually on the rise. How can we reduce the indoor air pollutant? In developing nations, maybe we could add plants to absorb toxins. Plants like spider plant or English ivy are very good at that. Maybe we can not allow smoking indoors, or we could install ventilation systems to basically make sure that the air is being circulated and the pollutants are being released outside. In developed nations, we can maintain all filters and vents, maybe clean the air ducts, monitor humidity levels to reduce mold and mildew. Also, test for radon gas by installing radon detectors, and we could use green cleaning products, and that could help us basically avoid formaldehyde. This will bring us to how can we reduce air pollutants. There are three main ways, uh, which is regulation, conservation, and technological improvements. When it comes to regulation, this is basically creation of bills and laws that will regulate the levels of air pollution and enforcing these laws by penalties, or maybe fines or jail time, anything like that. The major one is the Clean Air Act. This was addressed or addressed acid rain, ozone depletion, and toxic air pollutants such as carbon monoxide, carbon dioxide, sulfur dioxide, particulate matter, and ozone and lead. Since this act has been passed, there has been a 65 drop in all six major air pollutants, so this is actually working. The other one would be the CAFE standards. This is something that sets miles per gallon standards in the US, and it works by setting goals for nationwide averages on basically cars. How much mileage would the car basically be running per gallon? The current goal is 55 by 2025. We're almost there, so that's really good. The third one would be the cap and trade. This is where businesses are given a quota on the amount of pollution they can use. If the companies do not use their whole quota, they can sell it to some other businesses, or if they are going to use more, they can definitely buy it from other businesses. When it comes to conserving and reducing energy, we can use mass transit. This is going to um, lead individuals into moving away from owning cars, maybe using subways, trains, and buses. We could work on improved city planning, so adding more walking areas, bike paths, such as in Vancouver. Reducing the urban sprawl. So, if there's any way that we could plan the city by reducing distance between citizens and residents and their work, that would be very great. This is called mixed zoning. The third thing that could be done is investing in smart appliances, so more energy efficient appliances that do not need a lot of insulation. They can work through without actually a lot of insulation, which, like we mentioned, it can include formaldehyde. When it comes to improvements in technology, those improvements can actually capture pollution and improve the energy efficiency. The first one that we're going to be discussing is the electrostatic precipitators. Those basically, what they do is they eliminate the solid particulates from the exhaust gas, and they are widely used in steel plants and thermal energy plants. They are very, very a smart way, if I might say, to filter the air in those smokestacks. What they do is when particulate matter is released during the burning of coal, it runs through a negatively charged metal, which is basically what you see right here. And this is basically this particulate matter picks up the negative charge from this grid and continues through the smokestack. When it continues upwards, what happens is that it reaches a positively charged plate that lines up the smokestacks on both sides, and they kind of get attracted to it. Eventually, they are collected right here in those trays, and the air that leaves the smokestacks becomes a clean air. The other one is what we call the wet and dry scrubbers. Those can remove air pollutants through chemicals in solutions or simply filters. Wet scrubbers, water is used, and through some type of chemical reaction, the air is now filtered and it's leaving as a clean air. The third one is a catalytic converter. Those are the ones that basically are installed in cars, new models, obviously. And they basically change the car emissions into safer alternatives. And those filters are mandatory now in most states to reduce the VOC emissions, and obviously they change a lot of pollutants into safer compounds such as nitrogen oxides are changed, if I might say, to nitrogen and oxygen, carbon monoxides to carbon and oxygen, carbon dioxide and oxygen. So those are like a safer emissions than the ones that were supposed to be released. So the catalytic converters, like I mentioned, they change the carbon monoxide by oxidation reactions into carbon dioxide. They also change or reduce the nitrogen oxides to nitrogen gas, but they also change the hydrocarbons, the unburned hydrocarbons, to carbon dioxide and water. So all three pollutants are now changed into a safer version. We can also definitely use gas nozzles on fuel pumps so that we can avoid the release of VOCs. We can switch to alternative energy sources such as wind energy or hydroelectric, and that is definitely a better, cleaner form of energy. That would be it. Thank you.